Hey, so we are on section 1.3 today. It's called the segment addition postulate, also known as SAP. The first thing you might be wondering about is this weird word. What is a postulate? Well, a postulate is something that's accepted without proof. You were going to be talking about theorems later, and theorems require you to prove them, but a postulate is just so common sense that we accept it without proof. So you might think, well, this is going to be an easy day. If your algebra skills are good, it will be. If not, we might need to brush up on those a little bit. So our goal today is to find and compare the lengths on a segment. Remember, in the previous lessons, I said that lines are not measurable. They go forever in both directions. A ray is not measurable. It goes forever in one direction. But a line segment is measurable. It stops. And so we can actually go talk about their lengths. And so first up is, and as far as notes, I'd like you again to label this. Section 1.3, the segment addition postulate. And I would like you to write these down. So again, if I tell you to write it down, pause and either write it out, or if you're using the teacher copy, that's fine, or the student copy and cutting, pasting, I'll leave that up to you for this first chapter, and then the next chapter I might fine tune that a little bit. So when we talk about the length of a segment in terms of notation, so I'm going to go back and talk about yesterday. We talked about line AB going forever in both directions. We talked about ray AB starting at A and going forever to the right. We talked about segment AB ending at A and ending at B, so no arrows. Now, when we just talk about AB without anything over it, that means how long it is. So when it says what is DF, it means how long is segment DF. So the easiest thing to do, I think, is to just count. How far is it from D to F? So let's go write that down. The length of a segment. No symbol over the top. All right, so when I say BG equals, I want a number right here because without a symbol over the top, it means how long is it, what is its measure. So I like to, some books will say do right minus left. Let's go do that. So let's take G, which is at 1. And let's go take B, which is at -4. And some books will say you do the absolute value of what you get when you subtract them. So I'm going to do it 3 ways right now. Right minus left, you'd go 1 minus -4. When we subtract, we add the opposite and we get a 5. Some texts will say it's the absolute value. Remember what that is. Absolute value is always positive. So it doesn't matter if you go left minus right or right minus left. It's the absolute value of what you get when you subtract the 2. And again, by the 2, I mean the 2. I could have done 1 minus -4 or -4 minus 1. Notice when I drop 1 from -4, I'm at -5. Absolute value means distance from 0, which is always positive, which is 5. So that's how some texts teach it. Honestly, for me, I would just hop along the line. I would go like this. How far is it from B to G? Let's count. Let's put our pen at B and go 1, 2, 3, 4, 5, 5. I mean, honestly, it's easier, right? So if I were to ask, and again, you should be writing this in your notes. If I were to ask DA, let's go EA. Without any symbol over the top, it's a number, it's length. Well, I would just hop on E and start counting your hops. 1, 2, 3, 4, 4. Now, if you like to do what the book does, it's equal to the absolute value of -5 minus -1, which is -5 plus 1, which is -4 in absolute value. That's 4. Hop. It's easier. All right, so the segment addition postulate, also called SAP. what it says is, and again, I want you writing this down, the stuff that's highlighted, you might even want a highlighter out. Segment addition postulate is very, very straightforward. Okay, picture this as Highway 169. And we're going to travel from Zimmerman straight through Elk River and then head on to Rogers. It says that if you go from Zimmerman to Elk River, which is a distance of, what is it, like 6 miles maybe? And then you go from Elk River to Rogers, let's say 7 miles. You will get the distance from Zimmerman to Rogers. It basically just says that to get from the left to the right, you could just do 6 plus 7, and it's the whole way across. Pretty easy, right? So practice with numbers down here. What it says is, like, say if I go from B to C, plus from C to G, now let's travel there with my pen, B to C, plus from C to G, I could have just gone all the way from B to G. Now let's put the numbers on there. From B to C is 1 hop, plus from C to G is 1, 2, 3, 4 hops. The whole way better be 5 hops. I mean, it's so straightforward, right? You might say, I'm done with the notes, but there's some more coming, so just wait. So when you're using the segment addition postulate, you just got to really watch where these lengths go. So, and again, you should be pausing, putting this in your notes. If from E to F is 6, and from E to G is 21. Now, E to G is the whole way across. That would be like if I erased this 7 from Elk River to Rogers and told you the whole way across is 13. Then you have to say, all right, to get from Elk River to Rogers, I got to remove that 6 miles that I already went. So that's the same thing here. For me to figure out the length from F to G, remember with no symbol above it, it means its measure, its length, its distance. I would just do 21 the whole way minus the piece I already drove is equal to 15. So I would say FG equals 15. Now, be careful, because if it had said, you got to read these kind of carefully, if this one right here had said from F to G is 21, and then asked you for E to G, oh, oopsie crapola, then asked you for E to G, that's different, because then this piece is 6, the other piece is 21, and they're asking you for the whole weight, so then you'd add them. So you just got to be careful whether you're going to add those suckers up or subtract them. Now is where it gets a little trickier, okay? And your homework today is Delta Math, and it'll be your first time doing it for this class, and this is screenshot right out of there. So the first thing we need to do is draw a picture. And again, if you're not cutting this out of the student copy, or if you're not using directly my teacher copy, you should pause and write this in your notes. Minor examples we don't put in the notes, like yesterday there were some, but this is a big one. Like star this. This is worth lots of points on the test. You need to know how to do these. So first thing we're going to do is pause and write this in our notebook. Or pause and paste this strip in our notebook. Point U is on line segment TV. So I've got this line segment TV. So let's go TV. Point U is on it. So somewhere on it, again, just make a random picture is U. I've just taken care of that. This is called reading the text, and we're going to need to make a diagram from it. And you have to do this. Given that from T to V, and you have to decide, is that the whole way or is that a part of the way? And T to V is this whole way. So I'm going to hop all the way across here and put an X plus 10 on there. It's very careful that you don't just go throw it anywhere you want. It's from T to V. From T to U, this short little piece right here is 3x minus 8. And from U to V, this piece in blue is equal to 10. So now remember the two pieces have to add up to the whole way. That's really what the segment addition postulate says, is the two pieces add up to the whole way across. And that's how you set this up. You're going to grab the first piece plus the second piece has to be equal to the whole way across. You can't just throw them in however you want. And then it's algebra. So we have to remember how to do our algebra. We always go combine our like terms if we have them. -8 plus 10 is 2. Then we need to get the variable on one side by moving one of them over by doing the opposite operation. I'm going to choose to subtract x because I don't like negative, so I always grab that smaller. So 3x's minus 1x, that's what this really is 2x's there over on the left. So I have a 2x plus 2 here is equal to, this will be gone, 10. Trying to figure out what that x is. So to attack it, I need to get rid of the 2. Then divide both sides by 2. And I get x is equal to 4. And if this was Delta Math, if it asked you what's x, you would type in 4. But notice it doesn't. It says determine the length of t to v. So you have to go back up here. T to v is the red. It's the whole way. And to get that, it says I have to take x. My x was 4. And I have to add 10 to it. So TV is going to be x, which is 4, plus 10, which is equal to 14. Let's go see, though, just for the heck of it, what those other lengths are, shall we? So on this guy over here, if I do 3 times x, which is 12, minus 8, the yellow length ends up being 4. The blue one is just a 10. Do you notice how the piece plus the piece equaled the whole way across? It should, because we did it right? So this is what I would like you to do. I'd like you to pause this video and I'd like you to do this one on your own. And I'm going to be looking in those notes to see that, and I'm going to be asking you stuff in the note in the Edpuzzle about this one. Okay, so I'm not going to do this one with you, but you're going to do it the exact same way you did the other one. You're going to draw a segment EG. You're going to put F on it. You're going to go label the 3 things as either the one piece, the second piece, or the whole way across. And you're going to solve this one on your own, okay? And if you did it right, you should get, now I have to do it kind of on a sheet of paper over here, kind of figure it out here. We've got all right, so I'm not going to give you the answer. I'm going to actually have you guys do it. So make sure you put F on EG. Make sure you go label F to G 5x plus 1, E to G 5x plus 7, E to F 2x minus 2, and you say the piece plus the piece is the whole way across. Combine those like terms and attack the x and see what you get. But be careful, it doesn't ask you for what's x, so be very careful for that. That's why I didn't finish this one. It asks you for the length of EF. So you're going to have to go decide where you're going to put that x. So you're going to put it in here, or here, or here. All right, so that's your last one. Next up, I think I'm about done. All right, so congruent measures have the same, congruent segments have the same length. This is the symbol for congruent. It's an equals with a little squiggle. That should go in your notes, okay? Congruent means they have the same length. So bisect means to be cut in half. So if I take and bisect line AB, I'm going to cut it right here through the middle. And so then I know, I'm going to put an M for middle. I know that from A to M has to equal from M to B. Their measures are equal. Oh, I better make that guy an M, right? Their measures are equal. Those numbers are the same. Congruent means that the segments have the same measure. So equals and congruent are pretty close, but we, if this was 5 and this was 5, we'd say AM equals MB, 5 equals 5. But the segments are congruent. So again, bisect cuts in half. So let's go take a look, a little guided practice via worksheet 1.3. So had you been doing worksheet 1.3, but you're going to do Delta Math, you would have answered these questions. What is AC? You might say, oh, it's a line segment. No, it's not. Without a bar over it, it's the length from A to C. You can take and subtract them, 4 minus -4, put them in absolute value and say it's 8, because you add. Or, again, you can just hop from A to C and go 1, 2, 3, 4, 5, 6, 7, 8. Hops, boom. I don't care as long as you get there. The next one, if PR is 25, and again, for these you have to decide, is that the whole way or a piece? That's the whole way. I'm going to be adding up to 25. PQ is 12. Find QR. I don't know, but I'll call it X, and I'll say from P to Q plus from Q to R equals 25. So to solve that for X, I'd need to subtract the 12. All right, next it says L is the midpoint of KM. Okay, so L is right smack in the middle. What that means is the distances between K and L is equal to the distance between L and M. Or like I said, you could do it like this. KL is congruent to LM. That's the exact same thing. This symbol means if and only if. You're going to learn it later. If their measures are equal. The segments are congruent, the measures with the lengths are equal. So let's go set this up. K to L is 8x minus 5. That's this guy. L to M is 6x plus 3. That's this guy. And this is where sometimes kids will go, well, what's the whole way across? Well, that's not what I'm being asked. I'm being asked to find K to L. Because they told me this is in the middle, I'm not going to add these two up and set it equal to the whole way across. Because it's in the middle, it being L, I know these two sides are equal. So I'll say 8x minus 5 has to equal 6x plus 3. So notice the difference. You got to read very carefully. All right. So then there's no like terms to combine on either side. So I'll subtract 6x from both sides. I'll get it off of the right. 8x minus 6x is 2x. I'll add 5 to move that over onto the right-hand side. 3 plus 5 is 8. I get 2x equals 8. I divide both sides by 2 and I get x is equal to 4. Let's go see if it's right. Put in a 4 here and a 4 here. If I did this right, those better be equal because I was told that L is the midpoint. 8 times 4 is 32, minus 5 is 27 from here to here. 6 times 4 is 24, plus 3 is 27. So notice I have it right smack in the middle. 27 equals 27, or equivalently, the segment KL is congruent to the segment LM because their measures are equal. Okay, so your homework today will be Delta Math. There's more details about that in Schoology. You have a good one, and we are done.